Hello everyone, welcome back to another tutorial on C++. I think we're up to video 13, and this time I'm going to talk about arrays. I was going to do data all as one video, but that would be too large, so I'm going to break it up a little bit. I'm going to talk about arrays this time, and then vectors, and then probably lists, and then maps, and I think that'll be enough because they all kind of have their nuances and they have different use cases. So what we're going to do first of all is we're just going to make a new directory, and I'm going to call it data toots, I guess. And there we go. We'll change directory into it. Or actually, you know what? We'll just open this directory with Visual Studio Code, and you'll see there's nothing in it right now. We'll get rid of this welcome thing. I guess I could have clicked new file there on the welcome menu, but I'm just going to do that right here. Right click in data toots. Or there's other ways of making new files. I want to change directory into this folder anyway. The reason I'm doing all this is just because as a new coder, you want to get used to messing with files and doing it from the command line or from your editor. So just something you should probably get really used to. So I changed directory into this data toots folder, and I could make a new file here, or I could just do the touch thing that I like to do. There's a lot of different ways of doing this. People seem to have their own way of doing it. A lot of people like to echo to do files and write something into it, but I like to do just touch because it makes a blank file. So we're going to touch a new main.cpp, and there it appears. We're also going to go ahead and touch a Makefile, and there we go. And in our Makefile, first of all, we'll just make a default one that just compiles our main.cpp. That way we can just run plain old make, and it'll compile. And if we update our compile command later, we can just update this Makefile. So here's our main. We're going to start out with include IOStream because that's how we're going to display our data. We're going to have a main, and at the very end we're going to return 0. And here's going to be our meat and potatoes. We're going to talk about arrays. Now, what arrays are, let me preface this with a little bit of a scenario. Say you want to keep 5 different variables of the same type, and they're in order, and you might do something like this. I don't know, we'll say data 1 and a bunch of them, and then data 2, data 3, data 4, data 5, and this could be anything depending on your program. Maybe it's something like maybe you got 5 different attacks, so it's something like this. It could be anything that's in an order. So rather than keeping all of these separate, what you can do is you can just put them all as one, and you can say, okay, it's an int of attacks, and then you put these brackets on the end and end it like that. But this is underlined with squigglies because this brackets means it's an array, and C++ needs to know how many are in this array. That way it can allocate memory. So you have 5 attacks, we'll put 5 in there, and now it's happy. And what this is, it is 5 integers that are all lined up. And the great thing about them being perfectly aligned in memory is you can scan through them really fast. I'm going to change this back to data because it just makes more sense to me. So this can hold up to 5 pieces of data, and they're all lined up, as we went over, I think, in the second tutorial on some stuff about variables. The size of an integer is 1 byte, so this will be a total of 5 bytes, and they'll be nice and just lined up in memory. So if we ever want to flip through them, it's going to be super fast. But they all start out without anything assigned, or depending on your compiler, it just might be dummy data. So we'd want to initialize them, and this number of 5, or how many it starts out with, can't change with arrays, and that's sort of the drawback of them, but we'll get into that a little later. The drawback is once you set a size to them, it can't be changed unless you just completely start over and delete it and make a whole new one, which sometimes people do. And there's ways of doing that through functions and returning it and stuff like that. That's a little more complicated, so I'm not going to talk too much about that. But so what you want to do is you want to loop through this and basically just assign them all. So we'll start with we'll just do a for loop, and while I is less than 5, and then I plus plus, of course, and we'll say data at the ith spot equals 0. So we'll just set them all to 0. So as we run this program, it'll first allocate the 5 bytes for these 5 pieces of data, then it'll hit this loop. It'll go through it 5 times, and if you're questioning the 0 thing, well, these start at 0. So this isn't 1 through 5, it's 0 through 4. So that's important to note. Oh, by the way, as I've been doing before, tutorial C++ tutorial 13 arrays. That's where we're at. So this is 0, 1, 2, 3, 4. So that's why the for loop looks like this. It starts at 0. So we assign data at 0 location, and this is how later when you're calling it, you tell it which one to access. So first this will access 0, assign that to 0, then it'll flip to the next, it'll plus plus once and be 1, so then it'll assign data 1 at location 1 to 0, and data at location 2 to 0, data at location 3 to 0, and so on until it's and it continues while I is less than 5. So when I is 5, that would be off the array. And we don't want to do that, and that's why it's a less than. If it were less than equal to, this program would crash. But since it's less than, it only goes to 4. It goes right to the end of the memory and then stops, doesn't go any further. So if I show you this, you would see that it works. Now I'm just going to do another one of these loops just to get a little output going on. And I'm just going to, just so we can see what's going on here. So I'll do a standard cout, and I'll say data at, and I'll put an I here, and then I'll just do that, and we'll put a new line at the end of this. You know what? Rather than have it in that same line, I'm just going to do this on a new line itself. Now I could put that here. It doesn't matter. Either way is fine. There we go. So now if I run this, I should get a data at in all the I locations, and they should all be 0 because it's assigned to 0. So let's go ahead and run that and just confirm. So we're going to make, you know what? Actually, I'm going to do one little more advanced thing real quick just to help speed things up. Is I'm going to put in this Makefile another command called run that does the exact same thing, but also on the next line down, I'm going to put that it just launches our program. So anytime I put make run, it's going to go directly to this one. It's just a quick recap on Makefiles. If you type plain old make, it does the top one. It doesn't matter what it's named. I could name it this and it would run it. But if you want to specify exactly which one it runs, as you might have more, let's do a clear or a clean, and we're going to do we'll just do remove our a.exe, because that's a common one to have too. So now if we type make run, it's going to compile our program and it's going to run our program. And we can put over here too that it only compiles if this was updated. So what's over here, it checks the timestamp on and holds the timestamp on. If this was updated since the last compile, it'll recompile. If this hasn't been updated since the last compile, it will not run what's under here. Now this is a special case where we want to at least run this anyway. So and what would happen here is if this didn't get updated, it wouldn't execute this, so it wouldn't even run it, and we want to run no matter what. So we're going to leave that off here, and instead we're going to do this. We're going to say run our all, which is let me make sure, I'm going to see if I get this right. I think it's that. And this tells it to run this makefile in the all command, which would go up here, and that checks for the dependency of the main and decides whether it needs to recompile it. So it will just go to the next line after it handles that, and that way this run will compile no matter what. Let's see if I got it right the first time. I did. Awesome. So that's how you call another command within your makefile. It's just like that, and then the command's name. Like we could do something like this and make it clean every time. Maybe, you know, I like just to go a little further with Makefiles, as they're super handy. I'm going to make one called rebuild, and this one is going to do a let's see, it's going to do the clean command, and then it's going to, let's see, do we want to, I think we just want to compile no matter what on this one, so we'll do this. So there we go. A rebuild will do a clean and then an all run. And we could do that too anytime we want to just recompile. There we go. Which will just delete our executable. Our executable is going to get overwritten anyway, but just wanted to show you that example. So you can get fancy with these and do all sorts of things, and it doesn't even have to be C++ stuff. As you get better with the command line stuff, you can put any command line stuff in here, and that's the real beauty of Makefiles. They're not just for C++, but you definitely have to know them for coding. This tutorial is not about Makefiles, we already did those, but it just seemed relevant, so there you go. Hope that helps you guys out a little more if you were a little stuck on Makefiles still. And let's continue here. We got our data at, I did run that a bit ago, and it did work. And it is just showing all zeros. So if we want to assign them to the integer I, that should go 0 through 4. So let's do a make run on that, and there we go. Works as expected. They're all nice and aligned in memory. Now, one last thing I want to show you, or a couple last things actually, two last things, and I think I'm going to call it, I don't want this to go on too long, is there's two different ways people usually deal with these arrays. Like I just put the number in here, and you see I had to type it in multiple places to handle going through their right size. So okay, I guess three last things. I want to show you going off the array. So what happens if you go too far and you go off the array? Well, let's just do it. Did it recompile? Did it work? This should crash. I think maybe my compiler is being smart and not messing up, but if you go off the array, typically it'll crash. For some reason this is not. I think it's because I have a more modern compiler. GCC DAS version 7.3, so it might be autocorrecting for that, but I should be at least getting a warning that's being like, whoa dude, you're going off the array. Because what this is doing is this is probably writing to random parts of memory that aren't even accessible anymore, which could mess up other stuff on your computer. So I'm honestly very surprised that it's even allowing me to do that. I'm used to this sort of thing crashing. I think it's just because I'm on a more modern compiler than what I originally learned C++ on. So what I'm going to do here is I'm going to add a compiler directive that is called wall. So it's dash wall. So this is a compiler directive. This is sort of a new thing I haven't talked about before, but when you're compiling, you can tell your compiler to do certain things a certain way. And what this is, it stands for warning all. Now that's deceptive because of why it's called warning all. It doesn't actually show you all the warnings. I know, unintuitive, right? But you'll find a lot of stuff like that with programming. They just happen to get that name because it was the best name they could think of at the time, is all I can really figure that happened there. And if your Makefile is not working, by the way, make sure this is a tab. If you put in 4 spaces, it won't work. It's got to be a tab. In some editors, when you press tab, rather than actually tab over, they put in spaces. So watch out for that. You go to your settings if that's happening. And just FYI, that's pretty important. I know a million people who have been stuck on that forever and been like, I don't understand what's happening. So just saying that again. Okay, so warning all. Now if I compile, I'm just going to do run, which will call this one. up here, it should tell me all the warnings, and there's none. I'm baffled by this. This going off the array should blatantly yell at me and give me all sorts of warnings, and I don't understand why it's not. So I'm just full on baffled by that. I don't know. Let's try to spit out the data from like all these locations. Now this should certainly be some messed up data from random parts of memory, so who knows what it's going to say. It should crash. It should do a core dump. I don't understand why it's not. I flat out don't understand. There we go. So it looks like it is going through WTF. So that one's 45. That's pretty awkward, but what on earth is happening? So I actually need to look this up. This is a weird thing. If I only assigned it to be 5 bytes and I'm going way over it, it should not be functioning properly. It should be doing all sorts of weird stuff. So that's weird. Let me just do a few more tests here. Okay, there we go. So apparently it just lets you keep on assigning. Even with warning all, it doesn't give you a warning about this. Blows my mind. Okay, but here's a great example. I only assigned the first 5 of them, 0 through 4. So the rest are just random data from my memory. This negative huge number is like around the largest negative integer you can get. So, and then we got some 1s, 0s, 32s. So these are just bits of my memory that it's spitting out that are who knows what because I didn't assign them. So I don't know why. I'm not going to be able to explain that. I'm going to have to do some research to understand why, but don't do this. If you only make this 5 in size and you go way off of it, your program should crash, and it will crash eventually, because as you saw, even when we did assign it that one time, why it kind of worked, it for some reason puts data at 7 as 45. So it's not going to be consistent if you don't make this consistent, even if for some reason it doesn't crash on you to begin with, which it should. See, there we go. When we made it 45 in size to make it 45 bytes, the 7 one was okay. So apparently it's just force doing it anyway and just not giving a crap about what we do. This actually blows my mind that it's allowing this. Okay, well, I don't have a clear explanation from that, but don't do it. Make sure you only go to the size of your array. So that was going to be the point of that. I was supposed to show you a crash and explain that, but instead I learned that it's just going to let you do it, but assign maybe random ones wrong. And so yeah, keep it to the right size. So what people usually do is they do a say a const int. Well, actually, rather than an int, let's do unsigned int, because you can't have a negative size, so you don't need the sign. Unsigned int, and we'll call it, I'm going to do this in all caps, max size. It's traditional in programming to do your const as all capitalized. And we'll say max size equals 5, and that way, oops, copy, we can just replace all these 5s with max size, and we'll be sure we're never going off the array. And yeah, so if I run that, what's it complaining about? Oh, it's complaining about this comparison. This integer here is being compared to an unsigned integer, and since I have warning all on, it has given me a warning about the signed comparisons with, see a comparison between a signed and an unsigned integer. So that could cause some weird problems, so it gives you a warning, which is probably way less important than this, so mind blown. But yeah, so that's that. And since it can never be negative, we could just make these all unsigned integers, and that would be fine, and that would take care of our warning there. Optionally, we could just make this an integer, but since this can't be negative, like I said, we might as well make it unsigned. That way we can at least go higher, because the max unsigned int is higher than the max on an int, because int and unsigned int are the same size. They're both 1 byte, but unsigned int only handles all the pluses, so it has one more bit to work with, and essentially allows it to be twice as high as the max int. Okay, well, last thing, say you don't have this max size thing, and you're being fed some data. You don't know what size it is. Say it happens to be that size, and so you need to loop through it, but you don't know what size to loop through. So this is totally unknown. You don't know what this number is. Another trick to doing this is, well, you start your I at 0 as before, but you say while I is less than. Okay, so how do you get this number? That's what I'm going to show you. How do you get the size of this so you can loop through it? There's no traditional way, and that's kind of one of the drawbacks of arrays, but you can make it not so much of a drawback because you can get this number by doing a size of operation. Now, if you remember from one of the first tutorials, the size of, and if you do any data type, you do the size of this, you'll get the size of it. And since it's an integer, it'll just be how many are in it, because it's 1 byte per, and this tells you how many more bytes. So I'll do that. Size of data and bytes, I'll just make that explicit there, and it'll show you. And I'll go a little further with this just to cover all my bases. And here we go. Oh, it doesn't understand max size. Let's comment these out for the moment. And there we go. We'll get the size of data in bytes is 224,660. That's a little larger than we expected. So what is going on there? Well, we'll do size of divided by the size of an integer. Am I saying this wrong? Oh, I am. So all that I said earlier about an integer being 1 byte is wrong, as you're going to see in a sec. Sorry. Because the size of an integer is 4 bytes, and the size of an unsigned, they're all 4 bytes, not 1. A character's 1. So that was my mistake. And there we go. It gives us, since we have that warning all, it says unused variable, and that's because we're not using this anywhere in our code. So it does give you warnings about that when you have warning all, which can be handy because you can get rid of stuff that's not used. And the size of an int is 4 bytes. So that number we were seeing earlier, that's 4 times this number. Okay, and the point of me showing you all this here is you can get the size of this by taking the size of the entire thing and then dividing it by the size of whatever the data type is. So size of this entire thing divided by the size of the datas will give you the size of this array. So we should get this same number now. So let me go ahead and do a make run, and yeah, we got the right number. And what you can do with that is you can loop through with that number. You can just take this right here, put it in as the max size there, so while it's less than that, and you can go ahead and just loop through it. And now we're going to get a thing that goes on for a long time. There we go. So loop through all of them, and we didn't need to store this number because we just grabbed the size of it. So that's another way of handling looping through those, and it being whatever size, and you not have to change your for loops or not have to hold a constant. The disadvantage is you have to do this a little bit of math here on every loop, so that can slow down your program. So it might be a little better to do something like, let's see, well, I guess we can make it constant. Int size of data is what I'll call it here, and then get this. That way we only do this size calculation once, and we can grab this size of data and pop it in there, pop it in there, which if you're doing C++, you should care about speed. This could save you a little bit of time in your program's runtime. It's going to be so minuscule that no one's ever going to notice really, but That way at least doesn't have to do the same calculation a million times. Just saves it once, stores it in size of data. So there you go. I think that's all I'm going to say about arrays for now. I hope that helped you understand them and the potential pitfalls of them, ways to use them, different options for looping through them, and kind of the point of them. So advantage, they are the fastest data storage just because they're aligned in memory. Disadvantage, apparently the compiler lets you run over them and doesn't always crash when it should, but it will probably at some point. And looping through them, you don't necessarily know the size, but there are ways around that. So there you go. All right, thanks for watching this tutorial. I will see you in the next one. Keep on coding, guys, and keep it real. Don't forget to give this video a thumbs up. Leave a comment if you have any questions or any insights or maybe something I missed. That does help support this channel, just interacting in any way. So I would greatly appreciate that, and keep it real. Peace out.